Hello. So let's look at this. Take a triangle, okay, with a point D and take the parallel D to AC. Take the parallel passing by C to BD and the parallel passing by D to AC. Let's keep respectively E and F, crossing with AC, respectively AC and BC. And take the parallel from BC, from F to BA, and from F to BA from E, and then you've got some intersection point new, and you've got this figure, and it's very easy with the Thales theorem to see that all those lines are the distance between all those lines, the rapport of the smallest distance to the big one, the ratio from the smallest to the big one, is the same from the yellow line, then from the red line, then from the blue line. And also that those three triangles are equal. Okay, so now look at this. It is reminding me of the t-shirt of Mathologer. Now we are going to because Mathologer spoke about one particular case of what we are going to see. So I'm sure that as on his t-shirt there is a general case that I'm going to discuss. I'm sure that I'm kind of maybe spoiling him as he's planning to do a video in the future about this, or maybe I'm spoiling his subconscious. Okay, so now let's take this triangle, and now look at the line. Now look at the line, this line, okay, line EF. It is cutting. It is cutting the side of the triangle EF EIF in J. What is the ratio? The ratio is the same than we have the ratio between those two lines and those two lines, and it is also the ratio between those two lines and those two lines. In the see the blue, the light blue rectangle BIG. So this over this is equal to this over this is equal to this over this. So we've got the same ratio for IH over IE and EK over IE and EL over EF. And I will call those three lines, this one, and where is the other one? Okay, this one, and this one, sorry. So this one, I will call them the T median, where T will be the ratio between the small distance here and the big distance here between lines. Okay, so be careful. T is not the ratio between dB and dA that we took initially. We choose initially the point D. So dB and dA will be as dB and AI are equal. This will be something like R to the R plus 1. So that if this is 1 over n, the ratio, if this over this is 1 over n, the ratio of this over this is 1 over 1 to the 1 over n minus 1. So we can see the geometric sequence that is pointing here. No, I mean the harmonic sequence, I'm sorry. But what is funny here is that this triangle, so you can obtain it in two ways. You can say that this is the triangle obtained by scaling this from the same factor, BF to B, okay, BD to BA, BF to BC, and CE to CA, but this factor won't be R, it will be another one, so R to the R plus 1, R over R plus 1. So first, or we can say that is R prime, and that this ratio is R prime, and this one is R R under R minus 1. So this is the bijection. So we can get all we can get all from all for a random triangle. We can get the one that will give him by this transformation. Okay, so this is one way to transform this triangle to this one, but the other way is to construct the median, the T median, where T is the rapport of those two lines. Okay. Why do I say this? Because look now look at the yellow median. The yellow median is in fact, no, let's take the blue median. The blue median is a side of this triangle, okay, which is same shape than the big blue one, the big one. Sorry, and and this side IF is a T median of, well, I forgot to say T median. I mean I say median, but it's T median. So the T median anti-clockwise, no, clockwise of this one is the T is also is one is a side of the triangle IFE, and the T median of the triangle IFE clockwise, no, anti-clockwise this time, is one side of the triangle IBG. Obviously, I said clockwise and anti-clockwise because you can see that if I say just the rapport, the ratio, if I just give T to be the ratio from this to this, or from this to this, or from this to this, etc. I've got two choices for a median. I can take for example in the central triangle IFE, I've got this median, but I would have the symmetric one. For example, in the blue rectangle, I've got this. I could draw this would be a median, R to the R plus 1 median, and this one would be another R to the R plus 4 median. So we've got to distinguish them. So to distinguish them, we say this is a R over R plus 1 median clockwise, and this is the same anti-clockwise. Or we can say that if R is between 1 and 0, and a T median clockwise is a 1 minus T, I say R, no, if T is between 1 minus 1 and 0. Sometimes I say T, sometimes I say R, I'm sorry. When, oh, I've got to go, okay, but, so this exchange the medians, the T medians, but according to the other clockwise. If you square, but so what do you do if you take the dual of this one, and now wait, because I call it the dual, but I shouldn't. Why? Because if I take the same operation with this one, this will give me something smaller, but we don't care about size. We can, because we can scale it up. But what we will get will be another triangle particular. Haha, try to guess. It will be this one. So I let you know why. And or you can see it, so that's kind of nice. So you've got okay, and now if what happened if um, here this point here, this little triangle, we make it a point because the T median are have a non-empty intersection if and only if they are medians. And then we get back to the Matologer case. Okay, I will go further, but I've got to go. Bye bye.